Thanks everyone for joining the meeting, and hopefully it's 1 hour I will sort of communicate this really exciting project. As George said, I've been in this community for a very, very long time, more years than I would care to admit, probably. But I have never done something like this before with such a quick turnaround time. So this is the picture of Bristol. So if those of you have been to Bristol, this is the famous, Isambard Bridge. And that's where the systems are named after. So he was described as like Steve Jobs of his time. So today what I will talk about is like some intro bits. So you heard about me, but I will say a little bit more about me and what Isambard is and where University of Bristol and what they do. But most of the time I will spend talking about the story of Isambard AI, because it's really a kind of a story. Like I said, it's just, I still don't believe what has happened, but it's like a total fun and adventurous project. Then I will spend a little bit more time, although the talk is largely infra-focused, but I would like to really talk about what it is already and it can deliver for AI for science use cases, and a bit about what early users are doing and what happens next. So just to give you an idea, the first time we talked to the government about Isambard, it's not been 1 year since then. So it was like late August. And already in almost 11 months, we built and deployed a system that showed up in Green 500 at ISC. And we wrote a paper about how we built it. And it was such a unique thing that they gave us at the Cray user group meeting, they gave us like a runner of the best paper award while we had absolutely no results. It was about how we did it. So before I go further, I would really like to acknowledge, people who really made it possible. Because for a project of this scale, and the time scales and the complexity could not have happened without the support and commitment and dedication of a large group of people. And that starts from, people who funded us, the UK Departments of Science, Innovation and Technology, via UKRI and STFC, as well as, of course, suppliers, people at the university, because you could imagine from procurement to site preparation and everything, a lot was involved. Isambard really pretty much didn't start with a team. HPE, Nvidia, several contractors, people who build the modular data centers, the site we are located. So I just can't thank us. It was just a truly unbelievable experience. So we couldn't have done without it. So I'll start with like a very brief intro. So who am I? So I've been around, as was said, like, yeah, sometimes it looks like a very, very long time. And so for just over a year, I'm joined Bristol, but my role changed completely. So when I joined, no one knew, I didn't know. I just wanted a different thing, and this will happen. So now I'm the CTO there. Switzerland, I spent a lot of years. And again, that center grew at that time from 30 to 120. And I have had so many different roles and so many exciting things, including a lot of European projects. So I was in the architecture group for Euro HPC Lumi, and Phoenix is the other research infrastructure project that was funded out of Human Brain. Oak Ridge, again, really exciting time. At that time, the leadership computing facility was started in 2003 and growing, and before in Edinburgh and as a software engineer. So throughout my career, what I would say is the most privileged thing I have is, colleagues who have been mentoring and coaching me and this about. So this community is about people more than it's, of course, about technology and other things that excite us. So Bristol, University of Bristol is, as UK universities goes, is a fairly new university. It started not as a university, and you can read up its things, but it's one of the what they consider Red Brick Russell Group, the Ivy League equivalent university in the UK. And the Isambard project started as GW4 project. So GW4 stands for Great Western 4. So this was a consortium between the university in the southwest area of UK called Bath, Bristol, Cardiff, and Exeter. And they started this Isambard projects to prove ARM technology for mainstream high-performance computing. And recently, the Bristol School of Supercomputing BRICS has been formed because with substantial funding and mandate, we just couldn't continue as a separate entity inside, we needed a separate entity, and which is in the Faculty of Engineering. So now I start talking about Isambard AI as a story. So the first press release, the first time people heard about this is happening was this article that was published on 13th of September, where the UK government announced, what Isambard AI will be. It will be a research resource, very powerful system for doing AI for safety research, as well as AI for science. And the money came out from this 900 million investment that was proposed, what they call the Future of Computing report. So if you notice the date, 13th of September here, it was less than a month ago when we had our first call from the government. So it kind of gives you an idea how fast things were moving. And I will just give you a little bit more in a minute. So how Isambard AI is connected to the UK AI Safety Institute? So there is a link there, and if you can search, you can find it, when the government announced the UK AI Safety Institute. So essentially, there was a mission that the government wanted to pursue, which is about AI safety. And I copy-pasted some text from that. And within the same article, they say you can't do this work without having this ability to access very powerful resources, which for the most part, at least in the UK, are only available, through public cloud or other environment. And again, those are largely unaffordable. So this is the article that connects that mission to a compute infrastructure. And essentially, if you read it, the government in this case wanted to be like the forefront of regulation and legislation related to AI safety if those methods and tools are applied in a wider. They don't want to be in the same situation as when the social media kind of rise happen, where things happen, where governments have to act after the fact. So this is really the timeline, and it kind of gives you how things happen so quickly and rapidly, and what are the key markers in that time frame. So Isambard, as I mentioned, as Isambard 1 and 2, kind of existed almost from 2016 up until 2023. And the way it existed, it had no data center, in the sense that Isambard AI, Isambard 1 or 2 were small enough systems which were hosted within the UK Met Office data center, and that there was no dedicated team. So it was largely this GW4 team that was operating it. And we wrote a proposal for this funding for AI back in June, July timeframe. So like I said, on August 18 is the first time government gave back to us, and they say, we like your proposal, tell us more. And they liked it. And then we started the procurement in early September, which was finished within like a month. And at that time, the location of Isambard was still pretty much a car park at the National Composite Center, which you can see kind of above. And all this rush, and again, I do not have full confirmation, but the idea was that the UK government, especially the Prime Minister at the time, he was going to host this very high-profile summit. You can all see the picture here, which was called the AI Safety Summit, and you can see very important dignitaries down there. And the idea was that this announcement will come, or be aligned at that time. At least that's my theory. That's why things have to be happening so fast. in December, and that happened in November. So in December, we started hiring. So you see, not the whole team belongs there. This is a training course. So at that time, we were about 8 people in the team, plus me and the Simon person who was, and then there are some HPC training. So we were very fortunate to hire people in 2 months, 3 months time frame at that time. And in March, as the new team started, the modular data center was being deployed. So from December to March, pretty much a lot happened. The new team started, the data center was deployed, and Linpack and other, we had in fact had a deadline end of March to deploy Isambard AI phase 1 system, which is a smaller Grace-Hopper system, which you see the green 500 results for. And in May, after the software configuration, we already started running some of the inference benchmarks and some of the software stack. So one my colleague ran, it was this Microsoft Phi 3 Mini, and asked who is Isambard running on Isambard AI. And we are end of July here, 30th of July. We are already having early users and co-design projects that are proving the technical readiness of the system. So it happened, it's almost designed quite fast, but it can be done. And I will talk a little bit about how it can be done so quickly in a minute. So I define Isambard AI as I call it a series of fortunate events. So because we didn't go for this modular data center on purpose, it happened because the Met Office, who was hosting Isambard 1 and 2 ARM-based system, they decided to go with Microsoft for their next procurement or next set of procurements. So Isambard 3 was left with no option but to consider another hosting solution. And the options considered there, whether you could rent and place within existing center. And typically it's possible, but it's costly. And then most commercial data centers are not designed for high density compute rack, especially direct liquid cooled rack, which was an important requirement for sustainability for us. And building new takes a long time. We are in Germany, probably you can imagine easily how long and costly it could be. So that would not have met the timeline. So we consider these containerized data center or modular data center. So what is a modular data center? And on this picture, you see the picture of these 4 rows of car parks. Okay, these are UK-sized car parks, not I call it US-sized car parks. So and each of them have about 20 to 22 parking spaces. So it's not a very big space. It looks big here. And in a modular data center, what you do is you build it in, as we define, is a Lego block. So you can start building and tuning functional and performance elements, and then you can add more requirements such as high availability. So essentially everything from compute, network storage, UPS, power, as well as the cooling infrastructure is all inclusive. And there are options. If the sites have their own power cooling infrastructure, they can only build the IT part in there. So you can see the layout of both Isambard AI phase 1 and phase 3, the smaller system down below, which is the pod, and the thing, it already exists. And on the top part is where the scale out of 5,280 GPUs and storage and other infrastructure and transformer and the chillers will happen. This can be deployed quite efficiently and flexibly. And it can be done in months. So this is the part of the rapid deployment. So if you do not have an existing building or data center or infrastructure designed for this type of IT equipment, this could be one of the options to do it very, very, very quickly. And it can adopt different environmental conditions. So we went to the site which builds the ports in Netherlands, and they were building ports to go to some military and other sites. And then they offer you on-site integration as well as off-site integration option. Isambard is on-site integration option. Off-site is pretty much where they build the entire thing, including the IT equipment, and they just drop literally the solution on-site. It's highly sustainable. First of all, we get very fine-grained telemetry, the usage of environmental power, cooling through this data center environment. This is upgradable, refreshable in 10 to 15 years time, and majority of the components can be completely recycled. There. So I'll show you a video right now. I'll start it and then maybe narrate it a little bit. So they just started second week of, I think, December. So you can see already the car park being, dug up. And at that time, towards the back end is where the Isambard 3 concrete block is built, where it is, and you can see some of the placement of the infrastructure for chiller and Pumice-Kit. You can see the container is deployed so quickly, we don't even notice it. Now they are digging up things and laying the concrete for the phase 2. So Isambard AI phase 1 is already up and running in the far end there. The other thing was, I was joking with colleagues, it looks like it never stops raining. So you can see a little bit of water spots there on the camera in that time frame. So you can see in about 7 or 8 months, an entire data center is built and operation is started, and the next one is going to be built soon. So one of the things that was very important for us being at the university and being a public funded entity is sustainability. Because as we know, AI largely uses GPUs, and GPUs uses a lot of, and energy. So we said we need to design it in a way that we are doing it in a as responsible and sustainable way as possible. So this was considered in all aspects of Isambard AI. So in the procurement, although we pretty much wrote the procurement in less than a word, we wrote these targets, and then the vendors have to come back with the responses to this. I said the PUE should be way less than 1.1. I think in the good days with free cooling, we are targeting 1.034. We used other parameters like carbon usage of experiments, so we are not going to use any fossil fuel resources. And in the UK, it is possible to identify if you are procuring energy at the scale we will procure. And by being not in a sort of a commercial type of area or industrial area, there are options to reuse waste heat coming out of the data center. And this is also part of the plan. So University of Bristol, among its mission targets, they have net zero by 2030. So you could imagine when this proposal came along, everyone was very nervous, thinking they can just be completely thrown off the target by building, over a 5 megawatt IT system. So we asked the suppliers to categorize these scope 1, scope 2, scope 3 submissions. And I don't want to go into detail because this is not my area. So it's pretty much say what there is a scope 1 is nearly zero because there is very little, like a small diesel generator and other thing just to do for the functioning of UPS for a graceful slowdown. So it literally, in the bigger scheme of things, it doesn't generate any CO2. The second one is going to be by far from the grid, 90%. And the last one is, what is the supply chain carbon emission, which is difficult to estimate, but if you talk to main vendors or key vendors, they can tell you all the equipment they are delivering, how much CO2 emission they are doing. And the idea is, I think 90% is highly conservative. My understanding is majority, like 95%, if not higher, will be recycled, including the data center as part of it. So now I will say, and I already kind of say that this is the part which I think can give you idea. UK is a small country, so that's why space was kind of an important thing for us. So this is the Isambard site, which is located at the National Composite Center, which is a facility doing, as you can imagine, composite research and development. So the good thing, the reason the site was chosen was they had power available, sufficient power, as well as networking and cooling available because of the design of the facility, and they don't use it all the time. And then we can use some heating options. And again, it's one of the series of fortunate events things. So after the pandemic, they reported that the usage of their car parks in the best of days is like no more than 2/3. So this was the space really they were more than willing and happy to be used for something else. So in a way, the car park was available to us as a result of pandemic, and majority of the people now, at least part of the week working from home. And on the positive side, they are going to be one of our main users. So I would like you to just, keep an eye on the orange box thing, the orange rectangle thing I drew up there, because this was kind of the main constraint for us. And one of the questions I often get asked, they say, why did you build a Cray EX? It's not an AI machine, it's an exascale machine. Like this is the Frontier design or other Aurora design, EX4000 type of system or ALPS. These are typically HPC system. Why didn't you use DGX pods or super pod based design? So I tried explaining, and it was also in our procurement. If we go by publicly available information, a DGX SuperPod 256, which is optimized for large language model AI training, I would be needing a lot more racks just to accommodate the number of GPUs we were targeting at that point, which is a big screen. So if you look at the car park, I probably have to go all the way to the motorway. But there is more. So I have a big disclaimer in the bottom. All this information is gathered using publicly available information, or I ask ChatGPT. These days you ask ChatGPT, so I can report it back. So these are not certain numbers, and if you go through a commercial agreement, maybe these different. But through publicly available information, space we talked about already. How much if we go with the DGX SuperPod, what would we get? In terms of power, we have this 5 megawatt inclusive of everything, storage, management, and other ecosystem. And just looking at the power usage of an H100-based DGX, it is reported around 40 kilowatts. So if I just multiply without including everything, it would almost double, if not more. Then we looked at the TCO, total cost of ownership. So the capital expenditure is around, for Isambard, including the data center. So this is around 200 million. And when we checked it, they said a DGX SuperPod will be around tens of millions, if not more. So I took the value of 20 just to sort of lowball it, and it would be much higher. The biggest advantage of DGX type of solution, custom design, are really mature software stack that NVIDIA provides for AI and machine learning, which is not available as a given on a system we use, like using an HPC system to design the stack. So we are making progress both in terms of software stack, but also for storage. And how we are doing it is like this. So this is the picture our colleagues drew up within the Isambard team, talking to the AI users and AI Safety Institute. Majority of those users for their current usage and workflows are using public cloud. So the idea is we need to have a convergence of public cloud and HPC on Isambard AI. And you probably heard me talking about these things through my previous job at Swiss National Supercomputing Center and other. This is really the way to go for users and usage, not only from the ease of use and portability, but also for security. So at the top level, majority of AI and ML applications and frameworks that exist, both in public and private domain, they need to be enabled. And for the most part, the environment that enable it is people just full NVIDIA containers. Right now, if I really look at the majority of the usage on Isambard AI, people are doing some kind of a Docker pull or a singularity pull of NVIDIA containers, PyTorch, and other things. People who are installing these things natively, they are using Conda or some similar environment or VS Code or Conda. And I'm not suggesting that our typical HPC environments don't do that, but majority of the time, it's more about building a programming environment or compilers, native compilers. So already from the top layer, users are expecting a completely different stack. Then if we go one level down, what are the interfaces? The notebooks and the dashboards are by far the most commonly used environment. It doesn't mean people do not use Slurm and other job submission or custom graphical, which in the back end talk to Slurm. So we are really building two types of platform underneath the hood to talk to these interface. One is a Kubernetes running on the compute plane, as we call it, where it natively supports Jupyter Hub, Kubeflow, and other custom platform, as well as alongside there will be a shell. And I think I need maybe a different talk about running shell, running like Slurm in Kubernetes or Kubernetes Slurm. That is not how it is going to be, because we are creating multiple tenants and partitions on the compute node. So you could imagine if Isambard AI has like 5,000 nodes, it may well be the case at a given point, 3,000 to 4,000 nodes are managed through Slurm and about 1,000 are managed through multiple Kubernetes environment. I'm just giving you an example. We haven't decided on that, but it is not you are managing one resource management and scheduling system with the other, because they are completely different. And underneath the hood, the infrastructure management layer also needs to be very cloud native. In case of the Cray EX or HPE Cray EX system is the CSM Cray system management solution, which is microservices based. What is inside? So these are the direct liquid cooled compute cabinets, and for efficiency and sustainable performance and power efficiency sustainability. The good thing is the networking equipment are also liquid cooled. And inside that, we are using these new Nvidia Grace-Hopper superchips, which come with this chip-to-chip link, which provides very, very high bandwidth between CPU and GPU. So I've been using GPUs for scientific computing, like from my Oak Ridge time. And one of the things we were dreaming about when we will have like a single address space, and this is the architecture that really finally gets it. So inside a single blade or a single node, there are 4 Grace-Hopper chips that are connected through these NVLink link, and the picture is on the right. So altogether, a single node is way powerful for some of the AI inference applications that most people are using on public cloud. So you have 288 Grace cores, these ARM-based cores with 512 gigabytes of memory, 4 H100 GPUs, with a lot of memory and a lot of bandwidth. The overall aggregate memory, and this is very important, and this is the questions we have been asked. What is the size of model I can fit in before I have to do a distributed memory training? Because as you go from one address space to multiple, you need to worry about partitioning or scaling your model, which sometimes could be very complicated. So we were telling people that if your model size is just under 1 terabyte, you should be able to run it quite efficiently inside a single AI node. So altogether, by the time we are done with phase 1, we realized Isambard AI has done quite a few firsts already. We were just so busy we didn't realize. So HP told us this was their first direct liquid cool system inside a pod which was largely designed for air-cooled Isambard pre-rack. The time of deployment and power up in less than 2 weeks They say they never did it before. As you can see, I have a picture there. Never in my career, I was on a site wearing, hard hat and high-vis jacket. So that was like a personal best for me also. And then when in the scale out model, when we build the 5 megawatt, that will be, the combined direct and liquid cool system. For this time already is a direct liquid and water cool system together. So I chose the title of this talk is how to quickly deploy a system like AI. And I just thought when I finish the first part of the talk, I will give you a checklist. And the first two elements our checklist are about people and teams. So you need a team, you need a set of collaborators, you need your executive support and governance from people, all the stakeholders that are involved. I think if that is not there, you just can't do it in some sense. Then within that, you need a clear vision, really what you want to do and why you want to do it. And you need to be very goal-oriented. And our goal was to deliver a world-class federated digital infrastructure. And we have done that. Then becomes the technology enabling us, like modular data center we talked about, proven solutions. So I came from CSCS. I knew that this is the technology that can deliver it work and else is being required. So that kind of helped. And then because we want to get the users productive from day one, so having a mature AI and HPC software stack from HPE and Nvidia was really the key. So I will shift gears now and I will talk about what Isambard AI has already enabled and has a potential to enable more. And this is AI for science. Of course, there is AI safety research as well as AI from large language model-based research. But to me, our community, this is a very important thing. So there is this paper published last year from Nature. I call it's a very dense paper because I read it a couple of times and I think I probably get like a very small. But this paper does it. They say what AI is doing for science, and they give examples that AI for science is impacting the whole life cycle. So it's not just the first part, like hypothesis, experiment. AI has made substantial changes to each and every element of a scientific campaign. And as I highlighted in this, AI is moving from a computer science from early decades ago to a computational science domain. And what it's done, it is already doing, it aids in data collection and curation for scientific research. It's helping scientists to learn meaningful representation from scientific data. It's helping in generating scientific hypotheses. If you look at people, there are examples from all these domains, and AI-driven experimenting and simulation. Having said that, the thing that makes things stick and more credible or scientifically accurate is how your data and size of model comes about. As it grows, the capability increases. And there needs to be a lot of education and training over time to get this better understanding. What is the right model, size of model and data is required. And this is, I'm just putting it as an example here, not going into detail. So again, related to that paper, there was this article published which shows that in the US, when this medical exam was, the model was mature enough or trained enough that it can beat a human physician taking the same test. There, and these tests are not question answer. These are really complex tests. So it at some point it was able to bypass a human. So what are those emergent capabilities? And again, this is not my video. This is available from part. So if I just play it, you can see as the model and size grows for how the additional capabilities are being added. And this is where we are at. But in order to get there, you need a very large number of parameters, meaning large compute storage facilities, which are beyond the reach. At the same time, we have this situation where we have open and closed source model. And we are getting very, very large number. So this field is growing very fast. And for the most part, these are predicated on having access to very powerful compute resources like Isambard AI now in the public domain. So if I'm a typical AI user, I would usually start with a decent size laptop, because for the most part, a lot of work is done at that level. And this is the projection one of my colleagues did. He says, what would be possible with Isambard AI, which is not possible from laptop? I have another example with public cloud. And you can see the capabilities are just, enormous. So this helps a researcher and a scientist think of what they can do once they have access to this resource. We also did it because AI safety user, for instance, in the UK and other users, they are largely using public cloud for the most part, if not always. It's also Amazon. So we took a canonical instance that is used for AI and ML training, which you see Amazon EC2P5. And we sort of computed the value of this thing. And we said, if you take that instance and then you map it onto Isambard AI, how would you do it? In this case, of course, that instance has 8 H100. In our case, it will mean 2 nodes. And we sort of compared it. And then we also did, again, a lot of disclaimers that, if you go and do these things, you don't get the ticket or sticker price. We said, if that computation is done, Isambard AI versus Amazon, we are talking about the cost of ownership, about 1.9 million per day, but that doesn't mean anything. First of all, you get all these resources in one go, and typically they are split over multiple regions, and then you have to get a spatial memory, the AWS. So again, coming to the last part of my talk. So we have people running and using the machine. So this word cloud came from a form we asked them to fill, where they describe what they do. And already you can see there is a huge variety. We have, I think this is the data from 20 to 25 projects that fill out this form, and you can already see quite a bit of diversity, from refinement with transformer to simulation to video, LLM security, label classification. And the projects currently using Isambard are one using for drug discovery research using AlphaFold 2. Another very interesting project, which was like fascinating for me, is looking at it, the sources of skin cancer samples. They said the majority of the training data is done with light skin color thing, and they wanted to see how this biases impact the skin cancer research. A Brit LLM is another, and then the Galaxy image is looking how the ImageNet, and so applying like different methods and models. So there is just huge variety, which I'm not going to say doesn't happen in classical simulation-based HPC center, but this was quite diverse. I wasn't expecting that. Again, looking at another breakdown, this is the data coming from users who are running on the system. They filled out the application. So you can see they are doing a range, and some people are using one or more methods. So AI safety one, but some people are only doing training, some are doing inference, but some are doing a combination of both, and different type of training and inference methods. So these things will inform us how we tune and calibrate Isambard AI as a digital research infrastructure going forward for doing AI for science research. In terms of applications and frameworks, so more often than not, I hear this thing, oh, it's all about PyTorch, which is correct. Underneath the hood, a lot of people will be using PyTorch, but a PyTorch alone will not make it as an AI platform. And here you see already with limited number of users and applications, they use like a combination of frameworks and applications and methods, and some could be in-house. What we are doing right now, as I indicated earlier, we are evolving our software stack for AI users, and I hope together with the user as well as Nvidia vendor and suppliers in there. So in this picture, the figure comes from Future of Compute report, which announced this 900 million pound funding for AI, Exascale, and other research. And here they compared the classic HPC simulation-based use cases with AI users or use cases. And this was kind of the thing we used to motivate and drive us to design also the software stack for the user. I think the important thing to note here is Isambard AI is designed for all tiers. Like typically in HPC systems, we talk about tier 0, tier 1, 2 system, and we sort of discriminate who are there. We are not discriminating different tier user. If someone is using one GPU is as important someone using the whole machine. So one step is done, next step is coming. So the phase 1 system is already deployed, up and running. You saw the results, you saw the awards. I mean, it's still sometimes a bit unbelievable. And you can see the specs on the left side. On the right side, the specs are for the phase 2 system. And so I think I just copied pasted this slide from my other. So there is a bit of delay for the site readiness. So it's not arriving in summer, it's now in autumn. And when that thing is installed and deployed, it will be 12 EX 4000 cabinets with 5,280 GPUs. One of the things that is very exciting for me at this is for this system is the storage. We are getting more Lustre high performance type of storage, but we are also getting a software defined storage VAS that allows us to enable the use cases we can't enable for safety security reason on a shared parallel file system. With that, I finish, and I think I pretty much stayed on time. So this is the picture from this UK AI Safety Summit back in November last year, where they agreed on how they will proceed as an international community. So I'm really looking forward to Isambard contributing to that scientific research and collaboration.
Thank you, Sadaf, and congratulations on this feat. This is just amazing. It was brilliant to hear all the infrastructure details. It's a very broad angle question. If you did this all over again, what would be a couple of things that you would, probably redo it differently, or what were the immediate challenges that you think you would do it differently?
So, yeah, I mean, so sometimes when people ask me that, why did you do it? I said, it's like asking someone who do extreme sports, why do they do that? It's just like this small bit of early. I think it's very difficult to sort of tell for me for now, and maybe others can tell what would I do differently, because putting myself in a situation where we have no data center, no team, and still having this belief that it can be done, it could be just so there is maybe one thing. If I think the question to ask is, if the government gave us more time, what would we have done differently? I would say that if we had given more time, I would do a bit of more co-design with the teams, which we are doing now, ahead of time. And so the system is even more mature when it goes to, or get mature more quickly in terms of software stack. If it is, it has direct feedback and input from the end users and researchers. So that is something I felt like we just really we were going so fast and were being, how do I say, occupied with procurement, legislative, administrative, all these things. We really didn't have any bandwidth to do that part. So I think that would be one of the things I would probably consider doing differently. On the other hand, I don't know. I mean, the way I look at it is this project creates a new baseline for how we build large-scale systems across the, I have US experience, Swiss experience, have looked closely in Europe. what are the pros and cons for doing it, like taking your time and doing it in 2 to 3 years time frame versus doing it like that, where you can start generating value from your investment very quickly. So I would wait for that part to sort of be done once we scale out, because I don't want to claim success. It's done just now. So I think that would be another thing to look at. It is this new baseline is the baseline that other centers or sites could follow or not, or it was just so unique one-off to the UK and for this situation. Okay. So that's what, but I need a little bit more quiet time to reflect.
Good luck with that. But thank you very much. Thank you, Jörg.
Okay, there's a question in the chat. For the procurement step, which benchmarks were used?
Oh, that's a very interesting question. So let me give you maybe the timeline of the procurement that sort of gives you an idea. So the procurement was run in 1 week. So it was done in the framework agreement in the UK, completed in 2 weeks, and decision was in like the 4 weeks thing. So there was no time to send a benchmark and receive results. So we had very high level requirements for some of the peak speeds and feeds and some results for MLPerf, but we just didn't have, because if you look at from a vendor perspective, turning around for this scale, this size, and this value project in 2 weeks is not easy. So we were not very strict on getting any specific benchmark results. And if you look at the procurement, these were just the requirements talking about speeds and feeds and software stacks and other things. But in acceptance and other, we are using, classical HPC as well as MLPerf and other benchmarks. So it is done from an HPC procurement point of view completely differently from that perspective because of the time.
I have a question. This is a parking lot, right? And there's 5 megawatts or 6 of power consumption. So was it just sheer coincidence that there was a power line at the right place at the right time? And what do you do if you need more power at that point?
So there are plans, but in some ways we do not want to extend too much of this car park for reasons that, I can't go into detail, but the thing is that area without a lot of investment, we can go easily 4 to 5 megawatts. So there is enough capacity in the grid to extend it. And there is enough capacity to extend and go up to 30 megawatt, not too far from where Isambard AI car park is. Because eventually what we would like to do is, the idea is to do something what NASA did, like create, like, I know it sounds like totally crazy, a trailer park for for containers where you can just simply plug in things. So we can get, so that if there is additional investment and funding from the government in the near time frame, we would rather leverage the option of going up to 30 megawatt nearby than extending a few megawatts here. So that's kind of the thought process for us right now here. Because it is repurposing a car park in this case made sense at that time, but I think going beyond that just doesn't make sense for all sorts of other reasons. Yeah.
I have another one. So this is a UK-wide resource, right? How many people do you have in support for actual end user support, helping people with getting the software to run, educating scientists about the available frameworks and software and so on? How many people work in that sector?
I think, no, this is a very good question. And in fact, when Sunita asked her question, I should have mentioned this thing. Lessons learned. So, this is a great question. So as you know, I spent a lot of time in Switzerland. So in Switzerland, the way research infrastructure and other things are funded, the idea for resourcing and people for this project is we support the operation and we support generic platforms like Kubernetes shell with basic. If someone comes and builds like a custom environment, the idea is government needs to provide additional resources and other things. So currently our technical team doing everything is about, we will go up maybe up to 20 to 25, because the idea is that additional help and support in that environment will be supported by the UK government through a different funding. So from a user point of view, user perspective, this is the environment we will support. If anything goes above and beyond this, we will need more people for that. So to answer Sanita's question, what would I have done differently in addition to engaging people? This is another thing in terms of resourcing and people resourcing, understanding what type of skill set, requirement, training, building custom environment and platform would have benefited from that thought process as well. So currently we are very thin on the ground, but for the initial part, it works. And maybe if you ask me from 6 months from now, I will be saying something slightly differently.
As a follow-up question, you said that the hiring started at some point late in 2023, and there was also a very quick process. Are there any tips you can share how to do that effectively? Because you need all those experts, right? And they're not growing on trees.
Yeah, and we can't pay them like other companies and others. And
Exactly.
UK salaries are not, very high. So yeah, so again, this is one of these, you call them almost serendipity, and then there is support from the university executives. So we said we want to hire. So it looks like I have done a lot of hiring in US, Switzerland, and other. The main thing about hiring is you need to, from a technical job and role, you need to go back to candidates very quickly. So we said, if someone applies, we need to shortlist within a week, interview them in the next 2 weeks, and hire them in 4 weeks. Of course, you can add some buffer. So for the HR, university HR, that was really something very difficult, but they accommodated it. So that helped us a lot. So if someone was interested and involved and engaged, we were able to go there quickly. The other thing was very fortunate for us. It was a high visibility project, but the UK Met Office, currently with the model they are adopting going to public cloud, some people were very interested in this type of project. So we were very fortunate. I just can't believe it. It's still my luck till today that I was able to find people who knew HPE CSM management system. So it was like a combination of having the right support, being very aggressive in the timeline, targeting, and an element of luck. So we were able to hire 15 people in 2 to 3 months.